Welcome back on this channel. Today is the first video, the number 23 in English, this one, about the system 1 VFD for N motors. In this video, I will explain how to wire electrical parts in order to prepare the Raspberry Pi to receive the code. We will see in the next one how to set up the Pi, and in the last part, in the last video of this series, I will explain the code I developed it. Okay, let's go. Okay, you will find the wiring diagram on the link you can see on your screen. This link is written in the comments part in the window just under the video in YouTube. Okay, here is the diagram. Each line is a wire and each point is a junction. Okay, you can see here the Pi, here the VFD. Here you can see three relays. Actually, you will see that I use a board with four relays on it, but for this example, as we manage only 3 motors, we use only 3 blue relay on the small cards. And here are 3 bigger relays. So I will describe them specifically in a few seconds. Here you are the 3 motors. And here are the 3 remote control, one for each motors. This part here is there are emergency stop buttons. Okay, I will explain it in the last part of this video because they are wired in a very special way, and I think it would be very useful to know exactly how to connect them to the VFD. Okay, I started with a board, a very simple wood board, and the 2 small parts you can see here are just 2 bits of wood in order to rise up the board with the small relays, because you can find in the lower side of this card some electronical component, and I don't want them to be in contact with the wood because it can hurt them. The first thing to do is to place the VFD and the Raspberry Pi in the 2 up corners on the piece of wood. Okay, as you can see here, I simply screwed the VFD on the wood, and here for the Raspberry Pi, I use small parts you can find in a PC. They are between the motherboard and the box, the metal box, and you can find them everywhere, but you can take them from an old PC. It's free and it's okay. It works perfectly. You just have to screw them in the wood, pushing hard, and it will be okay to maintain the Raspberry Pi. So once you screwed those 2 parts, you have to create the power loop, which is in my case 220 volts, 3 phases. As you can see here, we have 3 wires distributed to those 3 relays by this system. It's very simple. And regarding those relays, please note that there are obviously three phases here, but you have an auxiliary contact on the 4th circuit here The last one, the fifth one, is the coil. Okay. Regarding the coil, I use 220 volt coils because then I can supply them directly with electricity provided by the network. I don't need to transform the electricity by using these coils. Okay, those relays are normally open relays. Normally, they don't let electricity going through. It means that you need to supply the coil to close the relay, and then the electricity will go through them. Okay, regarding this electricity, I mean 220 volt monophase, it arrives there, and then you will have to split two lines. The first one will supply the VFD here, and the second one will supply, will supply those relays. Okay, those relays, it's a very small card sold for a few euros. You can see here some cables. They go to the Raspberry Pi in order to change the relay position. Here are the relays. You need them because the Raspberry Pi is using 3 volts, and here to manage the coils on the big relays we need 220 volts, so you need to use a step between them. Here you have the picture, the whole picture of this system. Electricity arrives here, they go through these small relays. By the way, they are used in position normally open. Okay. When you close this relay, the electricity goes through the relay to the big one, to the big relay there. And as you can see here, we have the neutral or the phase coming here. Then if it's phase here, you have neutral here. If you close this relay, it will close this one. Then you will, with the small Raspberry with 3 volts, using the first relay and the second one, open or close the power loop for 223 phases current. Okay, we saw this part of the diagram, 220 volt monophase. We saw the 223 phases with the 3 relays. We saw this supply for the small relay going through the small relay to the bigger ones. So we can go future now. We talk about the 10 volt circuit. We are talking about actually the command loop of the VFD. As you can see here, we have only 4 inputs, x1, x2, x3, x4, on the VFD. And we use also the RS485 link. Here you have the plus, and just under you have the minus of this line, of this circuit. Here you have 3 other connections. We use them for the potentiometer we have on one remote control. And the last wire you see here is the COM. COM is very useful because when you close a circuit between COM and one among those 3 x1, 2, 3, 4 input, then you will send a signal to the VFD. I don't want to have several cable arriving on those on all those inputs, so I need to have only one wire going out, and then I will connect all the remote control together in another um, in another part. Okay. Here you can see AE1 plus 10 volt and GND cable. Okay, here you can see the RS 485 plus and minus. They are going just there on this connector. USB at the other hand, it will go to the USB 0 on the Raspberry Pi. USB 0 is the one on the left upper when you look at the faces with all the USB connector. Okay. Here is the place where those cables arrive. You have the COM here. You have X1, X2, X3, X4, and the three cables going to the potentiometer. Here you can see the three cables going to the three remote control. And here we have a special contact for emergency stop. I will explain emergency stop wiring in a few minutes. The important thing here to analyze is the fact that the COM, this one, doesn't go directly to the remote controls. It goes to the big relays on the auxiliary contact. You can see here, here, and here. This COM is very, very useful because you need it to make your button on remote control operational. What does it mean? It means that if you open the power supply, the power loop here, the relay are open, you don't have the COM going through the relay. So it means that if you want to have operational remote control, you need to close the relay. It also means that a remote control will never work without its relay closed. It's a good way to provide you from any problem by using a remote control and starting another machine. Okay, so here you have a general look, general vision of the power loop and on the common loop. Okay, you can see the COM going through the relay and going back to the remote control via this wire. You can see the relay here with the power, the COM, and the cause driven by the other small relays here. Okay, we just talked about this part of the scheme, of the diagram. The COM cable here, under the free relay, over there. We talk about all this part, I mean the cable going to the remote control here. We will have a look on them in a few seconds. Okay. And now we just talk about about the Raspberry Pi. Raspberry Pi is working under 3 volts. Okay, here on this Raspberry Pi you can see what we call the GPIO. GPIOs are some contacts you can use to exchange information with the rest of the world. I use this very old connector. You can find them easily, or you can get one from an old PC. It is exactly the same thing. You have 40 GPIOs, and it is very, very useful to get this connector because you can plug or unplug the 40 GPIOs at the same time without any mistake, and it's very, very useful. So I use exactly the same way than I had in the common loop. I mean that I use here something to screw all the cable coming from the GPIOs, and on the other part you will see the start here. Those cables are going through are going to the remote control. So all the white cables are going here, and then you go through and you go to the remote control. Okay, it was this part of the diagram. Okay, what you can see here is some resistors. The problem with any electronical circuit is that you have always some very small electricity, and it means that sometimes you, or very often actually, you are not on 0 volt or 3 volt, you are somewhere between 0 and 3, and it could be 2.5 or it could be 0.7, and it's really a problem because sometimes you are crossing the minimum and then the pi could decide to start itself some machine. And it's totally impossible when you are talking about a machine to bear the fact that the machine could start itself. That's what we call the floating entry, and it's very, very dangerous. So to solve this problem of floating entry, we just connect a high value resistor, about 50k ohm, between the GPIO and the GND. The 3 volts is going to the button, and it comes back to a GPIO, but the GPIO is also linked to the GND. So by this way, you can avoid any risk to have a floating entry. If you are interested in floating entry, you will find easily on the internet a very important literature explaining you how it works and how you can avoid them. But the main answer is by pull up or pull down resistor, you can avoid any problem, and that's exactly what I did here. Okay, let's have a look to the remote control now. It is the lower side of one of the 3 remote control. I remind you that all those remote controls are very different, just in order to illustrate that you can change from one remote control to another one very easily with this system. So here we have 2 buttons, normally open, it's written on it. So you have the brown cable coming here, which is the COM, and you have two other cables, white, blue, and yellow, who are going back to the VFD, and they are parameterized with jog forward and jog reverse. That's it. The other cable here come from the Pi. We will have a detailed view on it in a few seconds, but just note that there are 4 wires used, 2 for the button and 2 for the lights. The second remote control is here. You have a start button, a stop button, push button without auto maintain, and you will find in the manual a specific diagram to wire them. For the start button, you may use normally open push button, and for the stop you need a normally closed button. Okay. On this remote control, you will also have the potentiometer. You can see here 3 wire we used. And if I go back, you can see here a bit more specific button to reverse the way the motor is running. Okay, I will have a special speech about it at the end of this presentation, because normally if you have more than 4 input on your VFD, you just have to connect this button exactly like those ones. But as we have only 4 inputs, we need to find another solution, because if you use 2 inputs for emergency stop, one additional input for stop, one additional input for start, you don't have any more inputs for the reverse button. But unfortunately, we need it, so we have to find another solution. Okay, let's have a look on the button linked to the Raspberry Pi. You can see the green and the white wire. They are welded to the LED included in the button, and those 2 other wires, the brown and black and white, are linked on a normally open circuit. When you push on the button, you send a signal to the Raspberry Pi just to tell him that you want the motor you want to use to be supplied. There is a third remote control, simple one actually. Here we have a switch with 3 positions, 0, forward and reverse. So no specific problem with it. The brown is calm. You can see here another cable, another wire going to the reverse position. The white and brown and the blue are X1 and X2. X1 and X2. X1 is forward and X2 is reverse. What is interesting on this picture is the lower side of the emergency button. On this VFD, you need 2 circuits, 2 wires, for the emergency stop button. One is normally closed and the other one is normally open. On this VFD, you need a double circuits, one for going into the emergency stop and another one to go out of the emergency stop. And that's why you need a button like this one. It's quite different from other VFD. And you use the both normally open and normally closed circuits together when you push on the red button. Okay, and we will have a detail with the diagram, and you will understand it easily. Okay, we were just talking about those remote controls. So let's now have a look deeper on the emergency stop button. It may be more simple to have a look here. Here is the emergency stop. You can see that you have 3 wires. One is calm, linked here, and the 2 other ones are linked to X3 and X4 here. Okay, so X3 is normally open and X4 is normally closed. When you push on the button, you close the normally open and you open the normally closed circuits. That's exactly what you saw here. It's exactly the same thing. So let's have a look at that. X3, you wire in parallel the normally open buttons. It's the secret to inform the VFD that you want to stop in emergency mode the motor. The second one, X4, all the buttons, all the circuits are serialized. Okay, you can see you come from one button to another one before coming back to COM. Okay, so the normally open are mounted in parallel and the normally closed are mounted serialized. You can add additional emergency stop button if you want. There is no limit. As you can see here on this diagram, you can put them wherever you want. It means that I included one in the remote control, but you can put an emergency stop on a machine. You can put it on a remote control. You can put it near the door when you exit, or on the floor in order to help someone lying to just stop all the machine. Another point on this diagram is the fact that those buttons are connected directly to the VFD. It means that if you push on the emergency button, any emergency button, you will stop the VFD, so you will stop the motor. It means that if you see a problem 3 or 10 meters far from you, if you push on any VFD you find on this system, you will stop the running machine, even if you are not on this machine. The last thing I should mention is the fact that the VFD the emergency button directly drives the VFD. So it means that the Raspberry Pi is not informed that you pushed it on the emergency stop. Normally it should not be really a problem, but we have an issue with this kind of Enflixin 9500 VFD. It's very common, but sometimes some VFD, and this one does it, they restart when you go out from the emergency stop. They restart exactly at the same position that they were formerly. It means that if you were running a motor, you pushed it on the emergency stop and you released this emergency stop, automatically the motor will start again. So everyone doesn't want this. It's a very, very bad thing regarding security. So you will find many tutorials on the internet explaining you how to set up a relay, an additional relay on the command loop in order to avoid those spontaneously restart. In our case today, as the P is informed by the VFD via this link here between the relay included in the VFD and the GPIO on the Pi, you can avoid any spontaneous resume by stopping the motor in the P. by releasing, for example, all the parameters. So when you go out from emergency stop, you will have to re-choose an engine and push again on the start button. So you don't have this problem of spontaneous resuming of motors. Okay, I think so. Here is a picture of the couple of wires between the relay included in the VFD and the Raspberry Pi. Okay, we have a look on that, this part of the diagram. We explain the emergency button. The last thing I need to speak about is a special addendum for inflicting 9100 1 and 5 kilowatts. As I told you formerly, we have a problem with those only 4 inputs in the VFD. Those only 4 inputs are used 2 for emergency stop and 2 for start-stop command. If you want to have, if you want to change the way the engine is running, you need an additional button. So the most simple solution I found was to transfer this button from the VFD to the Raspberry. And that's exactly what we did here. You can see coming from this cable, which is the one is going to the Raspberry Pi. You have 2 wires here on a normally open push button, and you have 2 other cables used by this small LED, which is normally pushed in this hole. I just put it out to show it on the picture. It will, if you push on this button, if you press it, then via the ARS 485 link, the Raspberry Pi will explain to the VFD that you want to change the way it is running. Okay, and that's why you can see here. Where is it? Is it here? Okay, this is the button and this is the LED. They are linked to the Raspberry Pi with the resistor. And then, if you push on it, you will send the signal to the Pi to change the way it's running the VFD. So it will avoid you, or it will enable you to change the way you are working with the motor. Okay, I finished. Congrats if you asked, if you understood me. I apologize for my very bad English. And then I will meet you on the next video how to set up the Pi before including in the Pi the code and running the system. Thank you very much. Bye.